Right, so let's just go ahead and wrap up section 1.2, and we'll wrap it up with just a few practice problems so you can kind of get a taste for what it is that you need to be able to do. Now, so for each of these first two questions, I've already taken the liberty of using my calculator to RREF these matrices, okay? It'll just save us a little bit of time. So notice, so start with question 1. It says, find the general solution to the following linear system. Right? So they give us the augmented matrix, and we want to be able to find the general solution. So let's kind of do some step-by-steps, right? So first step is let's row reduce echelon form. Let's get that matrix, or original augmented matrix. Let's row reduce it. We use technology to save us time, but that gets us here. Now, remember, if you want the general solution, you got to go back to system. You got to go from matrix back to a system of equations. So now we have, let's go ahead and, again, this is x sub 1, x sub 2, x sub 3. So let's just translate this back to an equation form. So this is x sub 1 minus 8 x sub 3 is equal to negative 3. Then you have x sub 2 minus x sub 3 is equal to negative 1. So first step is REF. Second step is to go back to equation form, system form. And now the goal is going to be to solve for the basic variables. So we're going to solve for basic variables. So ready? So the basic variables, in this case, I think you can see x sub 1 is a basic variable, right? Pivot. X sub 2 is going to end up being a basic variable. Again, pivot. X sub 3 is going to be a free variable. So ready? Let's solve for the basic variables. So we end up with x sub 1 is equal to, well, we got negative 3 plus 8 x sub 3. X sub 2 is equal to, we got negative 1 plus x sub 3. Okay, so just solving for x sub 1, solving for x sub 2. Now, the last step, and this is honestly the one it's easy, but it's the one that's most commonly missed. You have to state that x sub 3 is free, right? So you have to state that it's a free variable. This is the general solution, or the parametric description of that system. And again, you can see that see how your basic variables are represented in terms of the free variables. You got to give me this x sub 3 before I can give you an x sub 1. Okay. Now, question 2, you're asked to do the exact same thing. Again, I've taken the liberty of, this is a larger matrix, but I've taken the liberty of running it through the row reduction algorithm. And that gets me to here. Okay, so at this point, you could start trying to say, okay, where's my pivot positions, pivot columns, but take a look at this. Remember, this is an augmented matrix. So right here is a problem. You cannot add up zeros and arrive at 5. So right here, this statement tells me that I wanted to get a general solution, but I can't, because this entire system is inconsistent. right? There's not even, consistent would mean there's at least one solution. Okay, in a scenario like this, there's an infinite amount of solutions. How do I do this? How do I explain this to you? Here's one, if you don't mind. I think this would make sense. This is inconsistent. If you choose x sub 3 is 0. Okay, so we're in 3 dimensions, 3 variables. We're in 3 dimensions. You just chose x sub 3 is 0. Remember, because x sub 3 is free. You can choose anything you want. So I'm going to plug 0 in for x sub 3 here and here. And let's figure out what x sub 1 and x sub 2 are. Ready? So if I plug 0 in for x sub, the first equation, x sub 1 is equal to negative 3. If I plug 0 into the second equation, x sub 2 is equal to negative 1. What am I trying to tell you? This is a point in space. This is a point in space that is one of the solutions to this system. Right? You can imagine some lines crossing each other at this point. But that's just one point. I could have chose x is 0 as what I chose. I could have chose x sub 3 is 1. Right? If I plugged a 1 in for x sub 3, that would be a new set of points. And I can continue, right? I can pick anything I want for x sub 3. So there is when you have free variables in a consistent system, you have infinite solutions. This is just one of those solutions. Now here, I didn't have a consistent system, so there's no way I can write the general solution. Question 3, and this will be the last question. It says, suppose that a 4x7 coefficient matrix. So let's go ahead and, so we got a 4x7. So 4x7, that would mean a pretty large matrix. So we got four rows and 7 columns. So I'm just going to put dots because I have no idea. So I have no idea what's inside the matrix. But 1, 2, 3, 4, 5, 6, 7. Sorry, there's no way I can speed up this process. So just make sure 1, 2, 3, 4, 5, 6, 7. Okay. So this would be a 4x7 matrix. All right, 4 rows, 7 columns. Okay. Now that let me see. Remember, it's a coefficient matrix, right? That's a key word there. Coefficient matrix. So coefficient matrix means there's no solution region, right? So sorry, there's no solution region. Okay, so suppose a 4x7 coefficient matrix for a system of equations has 4 pivots. Okay, so not every column is a pivot column. There's only 4 pivots. The first question is the system consistent? The next question is, if the system is consistent, how many solutions are there? Okay, well, this is so let's think about this for just a second. So let me see. So each of these columns is a variable, right? Remember, this is a coefficient matrix. There is no solution part. There's only the left-hand side of the equations. So okay, so let's try to think of it this way. So in other words, there's 7 columns, so that means there's 7 variables. Now, it's binary in the sense that each of these variables either is a basic variable or a free variable, right? But it can't be both. So either all 7 are basic variables, or all 7 are free variables, or some combination. Now, if it has 4 pivots, that would mean, if you can think, 4 pivots would translate into 4 basic variables. Well, if 4 of the 7 is basic, then 7 minus 4 is 3, so that would mean 3 of them are free. So I got 4 basic, 3 free variables. Adds up to 7. Now, it says, well, first off, is the system consistent? If the system is consistent, how many solutions are there? Let me go ahead and answer this. You would never do this. You would answer the first question before the second one, but I'm just going to go ahead and answer the second one. If this system, if it is consistent, here's what you want to ask yourself. So if it is consistent, either it has at least one solution, right? I'm going to say this, try to say it slow. If we assume that it is consistent, if there are any free variables, then there are infinite solutions. So if it is consistent, since we have three free variables, there are infinite solutions. But is it consistent? Well, I'm going to kind of scroll back to answer this question. Scroll back to the following theorem. And I have no choice but to read it in its entirety, and then I can try to give you an in other words. But this is the existence and uniqueness theorem. Ready? So it says, look, a linear system is consistent, right? At least has one solution. If and only if the rightmost column of your augmented matrix is not a pivot column. That is, if and only if an echelon form of the augmented matrix has no rows of the following form. So this form here, right, so it says B is any number but 0. So, for example, B could be 5. If you have anything like that, then we know that that would be inconsistent, right? Because you can't add up zeros and arrive at some non-zero number. Now, if a linear system is consistent, then, so that's the if part. If it is consistent, then the solution set contains either one unique solution when there are no free variables, or infinite solution when there is at least one free variable. So if your system is consistent and there's no free variables, then you are going to have one unique solution. However, if your system is consistent and there is even one free variable, then you will have infinite solutions. Okay. So in this case, we have 4 rows, 1 pivot for each row. So what I mean is, do you see how we have, if you have 4 pivots and you have 4 rows, then that means that you're going to have at least 1 pivot for each row. If that's the case, you will never run into the scenario where the system is inconsistent. So the answer to, is the system consistent? The answer is yes. 4 pivots, 4 rows. So 4 pivots, 4 rows. So that's 1 pivot for each row. So that's perfect. Now that it is consistent, how many solutions? Well, are there any free variables? Well, yes, there's 3 of them. So that means there are infinite solutions. All right, so that'll conclude the first 2 sections. See you in another video.